everyone, it's me, Mrs. Trombley again, here with your notes for section 3.3 on proportions. Our goal today is to be able to look at a pair of ratios and know if they are proportional. So the first thing you have to know is what proportional means and what a proportion is. A proportion is an equation stating that two ratios are equivalent. An equivalent is just a fancy word for equal. So two quantities that form a proportion are said to have a proportional relationship. All that means is that they are equal to one another. So for example, if I gave you the fraction 1/2, another fraction that would be equivalent to 1/2 is 5/10. So if we simplified 5/10, that would simplify back down to 1/2. So 1/2 and 5/10 form a proportion because the ratios are equivalent. So we would say that they have a proportional relationship. Something kind of special about this relationship: if I multiply the 1 by 5, I get 5. If I multiply 2 by 5, I get 10. So whatever you do to the top, if you do the same thing to the bottom, you end up having a proportional relationship. So that just means as the numerator doubles, the denominator doubles. If I triple the numerator, the denominator would triple, etc., etc. A kind of a fun example of something that's not proportional, just so we get the idea of what not proportional means. I have a special guest. It is Dora. Hola, mi amigos. ¿Cómo estás? So this is Dora. I love Dora. She's great. She only has one problem. Her head. Her head is just not proportional to the rest of her body. So as her body doubles, I think her head maybe triples or quadruples. So not proportional. Proportional relationships, as one aspect doubles or triples, so does the other aspect. And with her, it's just, she's nice and all, but she is not proportional. All right. So I said your job was to determine whether or not ratios form a proportion, and there are two ways to do that. The first way just involves simplifying fractions. So right now we're going to look at example A, and it's our job to determine if 4/10 and 10/25 can have an equal sign between them, because they can only have an equal sign in between them if they have a proportional relationship, if they are in fact equivalent. So to determine if these are equivalent, all we have to do is simplify each of them and see if they simplify to the same thing. So you can use your calculators for this. Again, to simplify a fraction on your calculator, you would type in 4 divided by 10, math, enter, enter. Or you can do it the good old-fashioned way. Find the GCF and divide each by it. The GCF of 4 and 10 is 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So 4/10 in simplest form is 2/5. 10/25, the GCF of 10/25 is 5. 10 divided by 5 is 2. 25 divided by 5 is 5. 2/5 does equal 2/5. So this means yes, woohoo, they are proportional to one another. So again, to determine if they're proportional, we simplified each one. If you get two ratios that are equivalent, that are the same, that means they have a proportional relationship. So I could put an equal sign in between the two of them. Example B, I have 6/4 and 8/12. We want to identify if this is a proportional relationship, if I can put an equal sign between the two of them. So we'll simplify each one. 6/4. 2 is the GCF. 6 divided by 2 is 3. 4 divided by 2 is 2. So 6/4 simplifies into 3/2. 8/12 has a GCF of 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. And some people might look at this and think, well, they're the same. This one has a 3 and a 2, and this one has a 3 and a 2. They're not equivalent. 3/2 is the reciprocal of 2/3. So these are not the same. They have to have both the same numerators and the same denominators. So this relationship is not proportional. I can't say that 6/4 and 8/12 are equivalent or proportional or are equal, because they do not simplify to the same exact thing. There is another way to determine if two ratios are proportional. And this way comes in handy, I think, if you have numbers that aren't as friendly as the ones that we just dealt with. If we have decimals in there or really large numbers that are difficult to simplify, there is something called a cross products property. And the cross products property just says that the cross products of a proportion are equal. Don't forget, products, that means multiplication. So I can show you, go back up to this first example. I have 1/2 and 5/10. We said that these two were proportional, that they were equivalent to one another. If I multiply and get the cross products, you can see that 2 times 5 is 10, and 1 times 10 is 10. That's what they mean by cross products are equal. When you multiply across, you get the same product for both. That works for every single proportional relationship. When you multiply across, if you get the same result, they are proportional. So instead of having to simplify each one, you could just multiply across to find out. So 1/2 and 2/4, I'm guessing a lot of you are looking at this saying, okay, Mrs. Tremblay, yes, we know 1/2 and 2/4 are equivalent. I chose this on purpose because we know these are equivalent, and I want to prove to you that this cross products thing works. So across from the 2 is another 2, so 2 times 2 needs to be equal to 1 times 4, and 2 times 2 is 4, and 1 times 4 is 4. That means that, yes, woohoo, they are proportional. So 1/2 and 2/4 are equal to one another. They have a proportional relationship. Example D, we have 6/8 and 3/4. To figure out if these are proportional, I'm going to multiply across. So 8 times 3 needs to be equal to 6 times 4. 8 times 3 is 24. 6 times 4 is 24. Because they are equal to one another, yes, this is also a proportion. We can put that equal sign there. 6/8 does equal 3/4 because they end up simplifying to the same exact thing. 5/7 and 2/3. Cross products, 7 times 2 needs to equal 5 times 3. 7 times 2 is 14. 5 times 3, it's 15. This is not proportional. So this is one of Dora's favorite examples because she is not proportional. Look at that. Look at that giant Dora head. Gotta love her. Bringing back the memories. Anyway, moving along. Okay, we now have everyone's favorite story problems. I prefer to call them math stories because I really think that you have enough problems. Teenage years are tough. I understand it, so I'm not going to give you any story problems. I'm just going to tell you some math stories. Ready for your first math story? Example F. You swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? So what they're really asking you is, are you swimming at the same rate? And we've learned about rates. One rate that's given is 4 laps in 24 minutes. Another rate that's given is 16 laps in 12 minutes. And another word for that in, we could throw per in there. So if I asked you to go ahead and write a rate for 4 laps per 2.4 minutes, we would write that as 4 laps per 2.4 minutes. Now what this is asking is 4 laps per 2.4 minutes equal to 16 laps in 12 minutes? That's the question. So to determine if these are equivalent, we could try to simplify 4 over 2.4 and 16/12 and see if they have the same simplified version. Or we can go ahead and use the cross products property. I'll start with the cross products property. It's kind of my favorite because it's fun to say. Cross products property. Try to say it really fast 3 times. You go ahead. I'll wait. Okay. 4 times 12 needs to equal 2.4 times 16. 4 times 12 is 48, and 2.4 times 16 is 38.4. These don't equal one another. Because they don't, that means no. The number of laps is not proportional to my time. That means I swam at 2 different rates, or you swam, it says, not me. My rates are always proportional when I swim. Anyway, moving along to the next math story. Backside of the page, you read the first 20 pages of your book in 25 minutes. You read 36 pages in 45 minutes. Is the number of pages read proportional to your time? So again, they give you 2 rates. 20 pages in 25 minutes is 1, and we would write that rate as 20 pages per 25 minutes. And I want to know, is that equal to, is that proportional to 36 pages per 45 minutes? Also notice, when we set these up, the pages are on the top in both, the minutes are on the bottom in both. That's important. You can't mix those up because the rate is pages per minute. Pages is your pages are your dependent, minutes are your independent. And it's always change in y over the change in x. So please keep that in mind. So in solving this one I see 20, 25, 36, 45. And when I look at those numbers, I think, I know those GCFs. The GCF of 20 and 25 is 5. So I'm going to see if these two simplify to the same thing. 20 25ths would simplify to 20 divided by 5 is 4. 25 divided by 5 is 5. This one simplifies to 4/5. 36 45ths has a GCF of 9. 36 divided by 9 is 4, and 45 divided by 9 is 5. So both of those ratios simplify to the same thing. That means that yes, these are proportional. Now you could have also chose to use the cross products property. You would take 25 times 36, and that should equal 20 times 45. When you take 25 times 36, you get a result of 900. And when you multiply 20 and 45, you also get 900. So you can see, either way you solve it, it's proportional. So it doesn't matter which way you use. When you do your assignments, I will not force you to use both ways. Choose one way. I think one way works best for some problems when they're easy to simplify, and the cross products works when you have decimals that aren't quite that easy to simplify. So choose your method. Either method will give you the same answer. All right, our final example, example H for hooray, we're almost done. Jack and Jill are in a little argument. She is saying that she scores more points than him, that she has a faster rate of scoring points. And Jack is saying, it's me, I am better. So let's see who the winner is. She scored 28 points in 3 games. That is a rate. It's 28 points per 3 games. He scored 112 points in 12 games. So again, 112 points, dependent, over 12 games, independent. All right, so I think I'm going to go with the cross products property on this one. I want to know, are these equivalent? So 28 times 12 needs to equal 3 times 112. So 28 times 12 is 336. 3 times 112 is also 336. So it is a tie. Jack and Jill tied. No one's better than the other. They are both the same. You could have also simplified these. 28 thirds, there's actually not a GCF other than 1. 28 thirds is already in simplest form. For 112 twelfths, the GCF of this is 4. 4 goes into 112 28 times. 4 goes into 12 3 times. So they would both end up simplifying to 28 thirds, which means that yes, they are proportional. I hope you enjoyed your lesson, and be prepared tomorrow with